Hey, all. So let's take a look at chapter 7. This overview is probably going to be one of the shortest because in reality, there's not anything. We've done everything. What we're going to do in chapter 7, we've done it all before already. So, what we are actually going to be doing now in chapter 7 is we're going to be looking inside of the beam or inside of the member. So, we're going to be looking at what kind of forces are inside of it. Those forces are going to be a shear force that tries to cut the beam in two, a moment force that tries to twist it into a smiley or a frowny face, and a normal force, right? Remember when we did tension and compression, right? That is the normal force, right? Is it being pulled apart or compressed together? So what we essentially are going to do is we're going to look at a body, we're going to cut that body in half, and we're going to have three forces, right? And then we can apply our equations of equilibrium to those forces and solve for those unknown forces. So here we have, right, an entire beam, right? Problem, we've done a problem just like this. I mean, we can look at this beam, we see that there's P1 and P2 being applied, two forces being applied to this beam. Looks like A is probably cantilever. It looks like a cantilever beam because we have an AX, an AY, and a moment at point A. Right? What we want to know, though, is what's happening at this point B internal to the beam. So the beam's been cleaved, and we can see that there is a normal force that comes out. There is a moment force that's going to try to twist it, and there is a shear force that's going to try to cut the beam. This is the positive convention. The ones on the left-hand side of your cut, the shear force goes down, MB comes out, and MB goes in. MB is actually always going to go in a way that tries to make a smiley face, if you can picture that. VB goes up on the right-hand side. So what are we going to do? We're going to place a cut where it asks us to place the cut. We're going to place our forces, and we're going to solve. I think I actually gave you all three of these. You might have to have support reactions. That depends on which side of the beam that you're going to do. For that previous example, if you did the left side of the beam, right, you would need those support reactions. But if you did the right side of the beam, right, you would not need the support reaction. So I would suggest doing the right side of the beam in that particular case. You're going to try your free body diagram. You're going to label your N, V, and M on your cut surface. Right? And last but not least, you're going to apply your equations of equilibrium to your free body diagram, and you're going to solve for those unknown forces. Right? Very similar to what we've been doing. We've been solving for external forces. Chapter 7 now looks at what's happening inside of the beam. There's your difference.